Physics Paper 1, Atomic Structure, Half-Lives and the Random Nature of Radioactive Decay. When calculating radioactive decay, it's important to have a calculator handy. Key knowledge, decay. As you can see from this simulation, decay is a random process. However, the overall behaviour of the system is still predictable. At each step in the simulation, you can see that the number of radioactive isotopes halve. Key vocabulary. I've just mentioned about radioactivity halving. Very often with radioactivity, we use the term half-life. This is the time it takes for the number of the nuclei of the isotope in a sample to halve, or the time it takes for the count rate or activity from a sample containing the isotope to fall to half its initial level. There's also the term net decline. This is only ever used in higher tier papers. This is the ratio of isotope present now to the initial isotope. Key equations. This equation really helps me answering these questions. So start activity divided by 2 to the n equals end activity. N is the number of half-lives and it's calculated by dividing total time by time of one half-life. Worked example, the half-life of cobalt-60 is 5 years. If there are 100 grams of cobalt-60 in a sample, calculate how much will be left after 15 years. Before heading into the guess method, I could work out how many half-lives there are. I've been given 15 years and their half-life is 5 years, so 15 divided by 5 equals 3 half-lives. Next, for the guess method. So what have I been given? I've been given that the starting mass was 100. I've now found out that n, the number of half-lives, is 3. Units are fine. Enter the equation that we've been provided. So start would be 100 divided by 2 to the power 3 will give me my end. Type that into the calculator and I get a mass of 12.5. Practice 1. The half-life of an unknown substance is 4 years. If there are 1200 grams of an unknown substance in a sample, how much will be left after 16 years? Calculate the net decline and express as a ratio. Pause the video and have a go. How did you get on? Now, before heading into the guess method, I would work out how many half-lives there are. I'd be given a total time of 16 years and each half-life is 4. So to work out my half-life, it would be 16 divided by 4 and this would give me 4 half-lives. A mark would be awarded for that on your GCSE paper. Now for the guess. What have I been given? Now I've been given a starting mass of 1200 grams and I have got 4 half-lives. So I've put start equals 1200, n for half-lives equals 4. Units are fine. Let's enter this information into an equation. So it will be 1200 divided by 2 to the power 4 and that will give me my end mass. That gives me 75. However, I have not expressed this as a ratio. So presently I have got 75. I started with 1200. So that gives me as my final answer. Practice 2, GCSE question. This time with a graph. The graph shows how the number of atoms of cerium-148 in a 120 gram sample changes over time. Determine the ratio of the number of cerium atoms in the sample when it was 100 seconds old compared with when the sample was 350 seconds old. Pause the video and have a go. How did you get on? For this question, I'd head straight over to the graph. I would note that my starting activity was 5. Half that is 2.5. Draw an arrow across from that to meet the line. Draw an arrow down, and this will give me a time of 50 seconds. That is the time of 1 half-life. I could also note from this graph that at 100 seconds, the number of atoms is 1.6. Now that I've determined that my half-life time is 50 seconds and my starting point is 1.6, I can use the guess method. So G, I've got the start as being 1.6. I need N, how many half-lives there are. So there's 50 into 250, that's the difference between 100 and 350. That is 5. Units are fine. Equation, start over 2 to the n will equal end. Substitute in 1.6 divided by 2 to the 5 equals, and that gives me 1.6 divided by 2 to the 5. That gives me an answer of 0.05. So I started off with 1.6, I ended up with 0.05, so the ratio is 0.05 to 1.6, and this would be better represented as 1 to 32. How did you get on? So here's the GCSE mark scheme. 1 mark given for the time of the half-life, 1 for stating how many half-lives there were in 250 seconds, 1 for providing a calculation for the correct ratio, and then 1 given for the correct ratio of 1 to 32.